so this is the last section in chapter 5. About half of this section, well, actually all of it except for the last two examples, you honestly already know how to do. So what we're going to be doing is we will be solving inequalities. We will be also solving rational equations. So first we'll start with solving by looking at a graph. So I'm going to ask you three different kinds of questions. I'm either going to ask you where the function is equal to 0. So when it's equal to 0, you're going to be looking for values that are on the x-axis. I may ask you where it is greater, where the function is greater than 0. In that case, you're looking for values that are above the x-axis. And then, of course, you've got the values that are less than 0. So those would be below the x-axis. Okay, so let's look at example number 1. You have your function. It's the graph in blue. So I want to know where that function is equal to 0. So I need to know where it actually crosses or hits the x-axis. If you notice, the x-axis is actually an asymptote. So those graphs are getting really close to it, okay, here, but it's never actually going to hit the x-axis. So there is really there's not a solution where it's equal to 0. Now we want to know where the graph is below 0. So that's going to be this part right here. Now notice whenever I'm asking for something for an inequality, you're going to be writing those answers using interval notation because we can't list all those numbers because we would be listing forever and ever and ever. So remember, whenever you're writing interval, when you're solving these, you want the x values, okay? So we're talking the x values that is going to make that graph go below the x-axis. So that's going to be this part of the graph right here. Okay, so the x values, that graph is going forever to the left. So that means it will be from negative infinity all the way up to this asymptote that we have right here, which that asymptote looks like it's at 1, let's see, 1, 2, 3. Looks like it's at 3. So it would go from negative infinity to 3, and it doesn't actually hit 3, okay, because and so that's the x values that will make that graph be below the x-axis. The other one is asking for it to be above the x-axis. So that's going to be this part of your graph. Again, we're asking for the x values. So that's going to begin at 3. Can't ever hit 3, but begin at 3 and it goes to infinity. Now let's look at this one. This one's a little bit odd. Okay, we need to see first, the first question is where it is equal to 0, right? So the equal to 0 means where it's actually going to hit the x-axis. So it looks like it's here and there. So it's actually going to hit the x-axis at -1 and at 0. Now, if you go back up to the beginning, when I ask for it to be equal to 0, the book really wants you to write the answer using set notation. So that just means I'm going to put those little brackets around it. So there's the two places that it's actually going to hit the x-axis. So now we need to know where it's going to be below the x-axis. Now, this one is a little bit different than the other one that we've had because this one is below or excuse me, that's above, that's below or equal to, okay? So it can be equal to. So basically, we're going to be looking at this part right here, from here to here, and from here to here. Notice that I have a hole, okay? So that means it can't be that one right there. So this is going to be a little bit tricky. We need it to go from this asymptote right here, which is -2. So it's going to be, let me do that in green. So it's going to be from -2 all the way up to, what's that right here? That's -1 right there to -1. Now notice at -1, it actually is 0, and we want it to be or equal to 0. So I'm going to put a bracket there because -1 actually works. Okay, that doesn't, sort of hard to look. Okay, there we go. Then we're going to go from 0 down to where the hole is, okay? So it's going to go from 0, and it can actually be 0 because it has an equal mark here, all the way down to this where the hole is, and that's where x is 1. We have to put parentheses there because it can't actually work at 1, okay? And then we're going to go from that hole all the way down to, what's this asymptote? 2. So that's going to be from 1 to 2, and it doesn't actually hit 2 because you have asymptotes. Notice these are always your x values. Some folks get confused and start putting y values in there. Okay, now we want to know where it is above the x-axis. So we have several places that it's above. Of course, we have this right here, that part of the graph, this part of the graph, and then we have this little part right there. So we need to give all the x values, right? So I'm going to erase this in a minute, but we're basically going to do these x values, and all of those x values, okay? So let me go back and erase that so it doesn't confuse us too much. Whoops. All right, so let's do the left. So for the left one, that's this one right here, it's going to go from -infinity all the way to, what is this, -2. So -infinity to -2 never hits -2 because it's an asymptote. Then we need this little part right there, and that's from -1 to 0. Now let's talk about if we need brackets or if we need parentheses. Notice that this is a greater than. It doesn't have the equal to mark. So that means it can't be -1 because that would give it equal to, and it can't be 0 because that would be equal to. And then the last part is this part right here, and that's going to go from, let's see, what's the x value? The x value is right there. So that would be 2, I guess. So from 2 to infinity. All right. So now we're going to progress from finding the value of an inequality given the graph. Now we're actually going to solve rational equations. Now you did this in Math 101 and a whole lot in Math 102. So you've already worked these before. Notice I'm going to work these, but there's also a YouTube video of it being worked. Of course, this is a YouTube video, but I wasn't planning on making YouTube videos when the semester started. So anyway, okay. So we need to find solutions without a calculator. Um, I've got fractions, and fractions in my book are not my friends. So I need to get rid of the fractions on the bottom. So you're going to do that by multiplying both sides by the common denominator, least common denominator. So to find that, I'm going to factor those bottoms. So this is going to be 2x plus 1 and 2x minus 1 if I factored it. These guys are already factored. So when you're finding the least common denominator, what I always do is I start with the first one, which is the one sitting right there that I factored, and I write down all those factors, 2x plus 1, 2x minus 1. Then I go to the next one, which would be this right here. And I say, okay, is that over there in my least common denominator? And here it is. See, if it wasn't, I would put it over there. Then I go to the next one, and I say, is that one in the common denominator? It already is. If it wasn't, I would go ahead and put it in there. So there's my least common denominator. So now I'm going to multiply every piece. Now, you could think of it as multiplying this side by that 2x plus 1, 2x minus 1. And then this whole side by that, 2x plus 1, 2x minus 1. But when I do that, I'm really multiplying each piece, right? Because I've got to distribute it. 2x plus 1, 2x minus 1. So I'm going to multiply each piece, and I'm going to go through and cancel. And if you have not canceled everything out on the bottom, you've messed up, okay? So the 2x plus 1 cancels, 2x minus 1 cancels. Of course, that was already done because I factored it. This one cancels, and this one cancels, okay? So notice there is nothing on the bottom. Everything is canceled out, okay? If that doesn't happen, then you've chosen the wrong least common denominator. All right, so now here's the hard part, okay? And that is just making sure that you have all the pieces when you finish, okay? So let's see what I have. I've got a 8x, so I'm going to write down 8x. And then my equal mark. I've got a 3 and I've got a 2x minus 1. So I'll have 3 and 2x minus 1. And then a plus 3 and a 2x plus 1. So now I've gotten rid of all my fractions, and I'm just going to go solve it for x. So, of course, we've got to get rid of all of my parentheses. I'm going to combine like terms. So I'm going to combine those guys together. Oh, look, my minus 3 and my plus 3 cancel out. Well, this is a little odd. Huh. Well, let's get all the x's on one side. I'm going to subtract 8x. You can move it, you could put the 12x if you wanted to. So I get 0 equals 4x. So that's basically saying 4 times what gives me 0. If I divide by 4, my x is going to be equal to 0. All right. Sort of, it ended a little weird, but that's okay. The first thing I've got to do, though, before I circle that and say that's my answer, is I need to make sure that it works in my denominators. So by works, I'm going to plug it in and make sure there's no 0. So if I put the 0 right here, I'm going to get a -1 in the bottom, and that's perfectly legal. If I put a 0 here, I'm going to get a +1 on the bottom, which I can have. And 2 times x, that gives me 0, and that gives me -1 on the bottom. So I don't get any zeros in the denominator. So my answer is x equals 0. All right, let's do another one. So again, remember I said the least common denominator. You're going to pick one of them. I'm going to pick this one. I'm going to write it down. I'm going to put an x. All right, then I come over to the next one. I need x squared. Do I have all that down there? I don't. I need another x. So I'm going to write x squared. Notice I don't need to write x squared and x. Okay, I don't need x to the third. It's very important you use the least common denominator in these. Otherwise, it's going to be very difficult to simplify. So notice that everything that's in my denominator, the x is included in there. Okay, and the x squared, of course, is in there. All right, so I'm going to multiply each piece by my x squared. Again, that's the same as multiplying this side by x squared and this side by x squared. Okay, but I like to write it like this. I'm going to multiply that by x squared and this by x squared. Now I'm going to go back through and cancel. Remember, when you finish canceling, there should be nothing on the bottom. Can't cancel anything in the first one because I don't have anything in the denominator. Now I'm going to cancel x goes into x squared one time, so I just have x, and those x squareds cancel. And I'm done. So let's go through and see what I have left over. So I have an x squared and a 1, so I'm just going to have x squared. Here I have a minus 3x, and then lastly I have minus 10, and then equals 0. So now we have a squared. So it's quadratic. So I'm going to try and factor it if I can. And you actually can, because 10, to get 10, you can use 2 and 5. And those guys subtract to give me 3. Put my negative here, my plus there to give me that -3. So that means your 102 teachers probably had you set each one of those equal to 0. But you could just look at that and say, what makes that 0? -2. What makes that 0? +5. Okay, so we're almost finished, but we can't just circle them because we need to make sure that I don't get a 0 on the bottom. So let's see if I'm going to get a 0 on the bottom if I plug in my -2. I don't get a 0 because that's not going to be 0. If I plug in my 5, put them in the bottom, I don't get any zeros on the bottom. So I actually have two answers, -2 and 5. I guess I could have put that in a set as well. Okay, let's do two more. Again, I'm going to factor this one right here, okay? So I'll have x and x. And the big hint, if you have these two, there's a good chance that that's the factors. So I'm pretty sure that that's going to be x plus 5 and x plus 3, and it does. If you full that out, you'll get x squared plus 8x plus 15. So my least common denominator, you can pick the big one if you want, or you can say, okay, I know I need this one, so I'm going to write it down, x plus 3. And I know I need this one, x plus 5. And then I'm going to look at this one, and I'll say, oh, look, x plus 3, x plus 5. I have that in my common denominator, so I'm done. So now I multiply each piece by that. Okay, so I'm going to multiply this one by x plus 3 and x plus 5. Same thing with this one. And the reason we're doing that is we're going to try and get rid of all my fractions on the bottom. So then I'm going to cancel out. Cancel the x plus 3's out. Cancel x plus 5's out. Same thing here. So I don't have anything in the denominator. Let's see what I have left. I'm going to go back to pink. I like pink. So we're going to have x plus, oh, well, maybe not, because you can't really see it. Okay. So let's see what's left. We've got an x plus 5 left here. We've got a 4, got a plus 4, and then my x plus 3. And then I just have a 2 on that side. So once again, I'm going to get rid of my parentheses. And I'm going to solve it. So I've got 5x plus 17 on that side. And I'm going to subtract the 17. And I'd get what? Minus 15. And when I divide, I get a -3. All right. So before we write that down as an answer, we need to make sure that it doesn't give me a negative in the bottom. Well, notice I put it right here. -3 plus 3, that's going to give me a 0, and I can't have a 0. So my only answer doesn't work. So this is a no solution problem. Can't get the solution to that. All right, one more, and then we'll take a break. Okay, so again, least common denominator. Again, I'm going to write the first one down, x minus 3. Then I'm going to write the next one down, x. And that's the only thing I got on the bottom. All right, so that's going to be my least common denominator. So I'm going to multiply each piece by that. Let's say x times x minus 3. I just like to write it like that. You can write it x minus 3 times x if you want to. Oops. Okay, so now we're going to go back through and we're going to cancel. Those cancel. Those cancel. So everything canceled from the bottom, which is what we wanted. And now let's see what I've got left. Let's do it in, I guess I'll go back to orange. So we've got our 2x and our x. So we're going to have, what, 2x squared in that one. We've got a 4 and an x minus 3, plus 4 and an x minus 3. And then we have all of this left, right? All of that left. So we've got 6x and x minus 3. And then anything times 0 is going to give me 0. So I need to go ahead and distribute everything. And then we've got some squares, right? So we have minus 4x squared. So there's that one and that one. Then let's get our, let's see, we got plus 12, let's see, plus 4, plus 4x. And then lastly, what's that? Plus 6 equals 0. All right. And, oh, I see where I messed up. Okay. I keep looking and I'm like, that's not what I got when I worked it out before. No, that's right. Okay. So I'm going to take out a minus 2. Okay. Because I can take out a 2. But I can't, I need to take out that minus, so I wind up with 2x squared minus 2x. What's that, minus 3 equals 0? All right. Now I see where I messed up. Okay, I'm sorry. When I distributed this one, that should have been an x. I kept looking and thinking, why am I not getting the same thing I did when I worked it out earlier? Okay, so that should be an x. Let's go back. Sorry about that. So I'm going to have minus 4x squared. Now I've got my x. There we go. I should have plus 22x and then minus 12. I hope that made sense. I hope it didn't confuse you. I just made a careless mistake and left my x off. Okay, so now I'm going to do the same thing. I'm going to take out what they have in common. And 4 doesn't go into 22, so I'll have to take out a 2. So minus 2, and so I wind up with 2x squared minus 11x, what, plus 6? All right, and I don't believe that that factors. So because I have a squared, I'm going to do the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so now we're going to plug it in. Negative b plus or minus the square root of negative b squared minus 4ac. I'm starting to run out of space, aren't I? Okay, all over 2a. So we wind up with 11 plus or minus the square root of 121 minus, what's that, 8 times 6, 48. 48, that should be 121. All over 4. So that's 11 plus or minus the square root of, what's that, 73 all over 4. And I can't do anything to the 73. I can't take anything out. So that is actually my answer. So you can leave it like this. I believe the back of the book leaves it like that. Some folks like to write it as 2 separate answers, one with a plus and one with the minus. So let's take a break and then we'll do the new part of this section.